Okay, part 2 of adding and subtracting rational expressions. So lesson 4. What it looks at in this section is how to add rational expressions in which the denominators have a common factor. So this would be such as adding something like 2/5 with 7/10. So there's a common factor between the 5 and the 10. So when you look at trying to factor these or trying to add them, it's not a good talking day. When you look at trying to add and subtract these rational expressions, start by factoring the denominators first, especially if the denominators are binomials and trinomials. Monomials you probably won't have to factor, but for the trinomials and the binomials you will. So if we look at class example number 1, it says perform the indicated operations, express final answers in lowest terms, and indicate the non-permissible values. So in question A, I've got a 5x and a 10x. So what would be my common denominator? 10x. So what would I have to multiply the first expression by in order to get to that common denominator of 10x? 2. So I multiply the top by 2 and I get
6.
And the second expression I don't need to change. So now I have 6 minus 3, which is, so my final answer becomes 3 over 10x. And my non-permissible value is that x cannot equal 0. Good. So if we look at B, we have a binomial for our denominators. The first thing that I want to check for is, can I factor that binomial in the first expression? So is this binomial factorable? Take out a 5. And what would that leave me with? Okay. Look at the second binomial. Can it also be factored? What can I remove? A 2. And what would that leave me with?
X plus 1.
So now in its factored form, I have a common factor, the x plus 1. So that is going to come to play in my common denominator. And then I look at the uncommon factors, which in this case are 2 rational numbers, 5 and 2. What's common? What's the common multiple for 5 and 2? 10. So my common denominator would have to have the 10. And then we go through writing equivalent rational expressions. So what do I have to multiply the first expression by to get to this denominator? 2. So multiply the top by 2 and I get 8. What do I multiply the second expression by? And what do I get? 15. And then when I add them together, I get 23. What's my non-permissible value? Okay. So x can equal -1. Okay, so let's take a look at C. I can't do anything to factor or to simplify the first expression, so we'll leave it as is. But can I factor the second expression? And what would that leave me with?
X plus 2.
So I'm going to get 1 over x times x plus 2. So if I look at my common denominator, this expression of x plus 2 has to be in the common denominator. Then I look at the 2 monomials, x squared and x. What would be the common denominator between those 2 expressions? x squared. So what do I have to multiply the first expression by?
X plus 2.
X plus 2. And if I multiply x plus 2 by 1, I simply get x plus 2. What would I have to multiply the second expression by?
X squared.
Would it be x squared? I already have an x. So how do I go from x to x squared? Multiply by x. So I'd multiply the top by x, and I'd get a negative x. So if I simplify the numerator, what do I get when I simplify x plus 2 minus x? Yes. And what can't x equal?
Zero, negative 2.
0 and negative 2. Okay, so we have 2 more examples, and then I'm going to let you work on some practice questions. So if we look at class example number 2, I have 5 over x plus 1 times x minus 2 plus 2 over x plus 1 times x minus 2. So when I go to determine my common denominator, what would be in my common denominator?
X minus 2.
X minus 2 is there because that's the common one. What else would I need? So remember what I said, the easiest way to get a common denominator is just multiply everything together. So I would multiply everything together in this row, but I don't need the x minus 2 twice. So I only put it in once, but then I have to put in the x plus 1 and the x plus 4. So you know that you've gotten a common denominator if when you look at the original denominator to the new one, this stuff is included in it. An x plus 1 and an x minus 2 is there. X plus 4 and x minus 2 are there. Even if it's the same x minus 2, that's fine. But as long as all of those factors are in there. So if we look back at this one, is x squared in my denominator? Yes, it is. Is x plus 2 in there? Yeah. Can I put x in here? Yeah, it's in the x squared. So that's what I need to make sure of with my common denominators. So what do I have to multiply the first expression by to get to this common denominator?
X plus 4.
X plus 4. So I'm going to take the 5 and multiply it by x plus 4. And what do I multiply the second one by?
X plus 1.
Okay. Remember what I said with the last lesson? Don't expand the bottom. We expand and we simplify the top, but we leave the bottom in factored form. So if I expand out the top, what would I get when I remove all the brackets?
X plus 20 plus 2x plus 8.
And then all of that is over that common denominator. And then the last step would be to collect all the like terms. So how many x's do I have? And what's my constant? And what are my non-permissible values? So go back to the original factored expression. We can go back to this step because they were all factored. So what can't x equal? What can't x equal here? negative 1. Here,
2.
and here,
Negative 4.
I'm not going to be a stickler if they're not in numerical order. It's easier if they're in numerical order to compare, but if you don't write them in numerical order, it's not going to be marks taken off. Okay, so we'll look at this example and then I'll give you some questions to work with. If we look at the first expression, 4 over p squared minus 1, can I factor p squared minus 1? It's a difference of squares. So p plus 1, p minus 1. This denominator of p plus 1 can't be factored, so I would leave it as is. Now I need to determine what is my common denominator. So remember what I said, to get the common denominator, we multiply everything together, but we don't need to include this second p plus 1 because it's already in there. So I'd have p plus 1 times p minus 1 would be my common denominator. And again, if I check, are these two factors in this one? Yes. Is this factor in the common? Yes. So I don't need to multiply the 4 by anything because this has not changed. The denominator is still the same. What would I multiply the 2 by? So when I remove the brackets, 4 plus 2p minus 2, and I get 2p. What's 4 minus 2? 2. Do you notice anything about 2p plus 2? Okay. And if I factor out a 2, now what can I do? Cancel out those p plus 1s, those common factors. I get 2 over p minus 1. And what are my restrictions? What can't p equal? Positive and negative 1. I go back up to this part in here. So I can't equal a negative 1, and I can't equal a positive 1. So if you look at the note, it says, if you notice in this example, the numerator had a factor in common with the denominator, which then resulted in a further reduction. We always have to check to make sure that our answers are expressed in simplest terms. So we leave the denominator unfactored, we simplify the numerator, and then when we get to this point here, where it's simplified and we've collected our like terms, we do a very quick check to see whether or not there's a common factor in here, or if this could be factored out. So I'd like you to work on question 1, B, and D, and 2C. When we deal with trinomial denominators, or trinomials in general, we start off by factoring the trinomial. So in 4a, the first expression is not factorable, so I will leave it as 2 over x plus 1. The second expression, the top, is x minus 1. I can't factor that. But the bottom, being x squared minus 2x minus 3, I can factor. That's by inspection. Two numbers that multiply to give me a negative 3 and add to give me a negative 2. Negative 3 and 1. So now I have x minus 3 and x plus 1 as my denominator for that second expression. Once I have my two expressions fully factored, then I can look at my common denominator. So what is my common denominator for this x plus 1 and x minus 3. So what do I have to multiply the first expression by?
X minus
And what do I multiply the second expression by? Negative 1. Or I don't have to multiply it by anything. There's no change. Remove my brackets. 2x minus 6 minus x plus 1. So I have minus the negative all over this denominator. Collect my like terms. I get, no, not 3x. X minus 5 over x plus 1 x minus 3. And what can't x equal?
3 and negative 1.
3 and negative 1. Okay, so I want you to talk me through the steps of how do I do B.
Rachel, what?
How do I do B?
What?
Why are you yelling at me? This is your kind of job. No. Factor by inspection.
Okay, so when I factor by inspection, what do I get?
I haven't figured that out yet.
Y minus 2 and y minus 1.
Yes. Factor the next trinomial. What do you get?
Y plus 2, y minus 1.
So what is my common denominator to add these two fractions?
Y minus 1, y minus 2, y plus 2.
Good. So what do I multiply the first expression by?
Y plus 2.
Yep. What do I multiply the second expression by?
Y minus
2.
And what is 3 times y minus 2?
3y minus 6.
I'll just break everything. It's all good. So 3y minus 6. Collect like terms. What do you get when you collect the like terms?
4y minus 1.
Is there anything else I can do?
You can factor out of 4.
And if I factor out a 4, what am I left with?
Y minus 1.
If I factor out a 4, leaves me with y minus 1.
And you can cancel it out.
So I can cancel out these common factors. And I get 4 over y minus 2 times y plus 2. And what can't y equal?
Negative 2, 1, and 2.
So positive and negative 2 and the 1. Remember, you have to go back up to this point right here. Actually, I have to go right up to the top. That's where I pick my restrictions, not from the final one, because if I had picked my restrictions from here, I would have forgotten about the positive 1. So it is always important that we go up to the beginning to pick our restrictions. Okay, 2 more examples. How does example 5 differ from the other ones?
Got to factor the top and the bottom.
Let's factor the top and the bottom. So if I factor the top, what do I get? Actually, I'll give you a moment. I want you guys to factor the tops and the bottoms and see what you get. So if I factor the numerator of the first expression, what do I get?
X minus 2, X minus 1.
And the denominator?
X minus 4, X minus 1. Subs.
And the x squared plus 10x plus 24?
X plus 6 and X plus 4.
And the denominator?
X plus 6 and X plus 2.
I'm actually going to move this over here.
There's two.
Okay, what do you notice?
You can cross out.
There's some common factors between the numerator and its denominator. I can't cross out this way. Like if there was an x minus 2 down here, I wouldn't be able to cross out those two. The only ones that I can cross out is from top to bottom. So if I cross out, I'm left with that. What would then be my common denominator?
X minus 4 times X plus 2.
Right. So what would I multiply this top one by?
X plus 2.
So I get x plus 2 times x minus 2 minus, and what do I multiply the other one by?
X minus 4.
What do I get when I multiply x plus 2 times x minus 2?
X squared minus 4.
X squared minus 4. It's a difference of squares. And when I multiply the other two, what would I get?
X squared minus 16.
Okay. Make sure you put brackets around that second expression because I have to subtract the entire expression. So now I have x squared minus x squared, which would equal 0. And negative 4 minus negative 16.
12.
12. So I'd have 12 over x minus 4 times x plus 2. And what would be my non-permissible values? What can't x equal?
Negative 2. Negative 6. 1. And 4.
Good. So we go back up to this expression right here before I started canceling things out. Because if I put a negative 6, into the original equation, this is going to equal 0, and then I'm done. So negative 6, even though it works here, does not work at the very top. Okay, so we're going to show that this expression simplifies to equal negative 7 over a plus 4 times a minus 3. So it would be my first step. Back to the bottom. So when I factor a squared plus 7a plus 12, what do I get?
A plus 4 and A plus 3.
And when I factor the second expression, first of all, what kind of expression is 9 minus a squared? Difference of squares. And when I factor the difference of squares, what do I get?
3 minus A, 3 plus A.
Okay. Now, it's kind of a little bit backwards, isn't it? What could I have done to make this the right way? So, can I switch these two around without any problems? Yeah? Because I could get an a plus 3. if I switch those two around, what do I get?
Negative
I get a negative a plus 3. And how can I make that a positive a? Take out a negative 1. So I'm going to show you something that you could do right up at the top. If I had rewritten this as a negative a squared plus 9, and then taken the negative a out, or sorry, not negative a, negative 1 out, I would have had a negative 1 times a squared plus 9, which when I went to factor would now give me my a plus 3 and a minus 3. So it would have factored more better. Negative 1 times a positive 1 would be negative. So instead of writing plus these two, we're going to subtract them. So now I can identify my common denominator. What would my common denominator be? So a plus 4 times a plus 3 times a minus 3. So what do I have to multiply the 2a plus 7 by? And this I now think of as being a negative 2a because of that minus sign between them. And what would I multiply it by? A plus 4. Okay, so I want you guys to multiply this and then collect the like terms and tell me what you get. So when I multiply this out, what do I get when I multiply here? What's the trinomial?
2a squared plus a minus 21.
That's the final answer? Like when you collected like terms on both sides, or? Because I would get minus 13a. Would it be? Or did I write that wrong?
Oh,
So-
isn't it plus 7, not
Oh yeah, that would be why. Okay, that makes more sense. Okay, so 2a squared plus a minus 21 minus 2a squared minus 8a all over all of this stuff. So collect the like terms. 2a squared minus a squared
cancels out.
cancels out. And then I've got a minus 8a.
Negative 7a.
So I get a negative 7a over 21 over all of this stuff again. It's probably the most tedious part about doing these questions is having to write out the denominator all the time. What do I notice about negative 7a and negative 21? And if I factor out a negative 7, I'm left with a plus 3. Which then cancels the a plus 3 on the bottom. And I now have the negative 7 over a plus 4 times a minus 3. Okay, so our non-permissible values is a can't equal positive and negative 3 and negative 4. So even though the question doesn't ask for the non-permissible values, we need to keep in the habit of always trying to include them because they are a part of the solution.